So the next concept you'll need to know for Unit 6 is the idea of the Riemann sum, which helps us approximate or estimate the area under the curve. The good news is that at its core, it actually uses a very simple formula, which is just the formula for the area of the rectangle. So all you have to do is you have to find the width of each rectangle, which is going to be the same for all of the rectangles that you choose. Then you have to multiply it by the height. That I think is a little harder to kind of conceptualize, but really all you're doing is you're taking your x values, which are going to depend on whether you choose to do left hand, right hand, or midpoint approximation, and then you plug them into the function to get the height. So I did do a separate video on Riemann sums that goes into that in more depth, but for now, I'm going to leave it at that and go ahead and move on. I do want to talk about how Riemann sums relate to the definite integral. So basically, again, Riemann sums are an approximation, and the definite integral allows us to get the exact area. So again, I'm not going to go through this, but I do want to just kind of highlight this here. This is showing an example. So if we had the function x squared on the closed interval 0 to 2, a question might ask you to approximate the area, again, using Riemann sums. And then for part B, if it says calculate the exact area, that's when you're going to use the definite integral. All right, let's go ahead and move on.